So I'm going to kick this off actually by talking about data-driven drilling decisions, right? Energy companies are leveraging IoT sensor data to make critical data-driven decisions. It could be from optimizing operations, enhancing efficiencies, and fundamentally looking at tackling sustainability challenges. These decisions could be used from like energy management to operational adjustments to strategic planning. Today's demo, we're actually going to be looking at an industry-focused scenario where we take a client on a journey from landing IT/OT data that comes from specifically drilling sensors, from drilling equipment. But it could be a BOP, it could be a drill string itself, or it could be the KLE, and then linking it to a drilling equipment chatbot to have a better understanding of what's going on with the equipment itself and highlight potentially how it's being built or using a unified data platform. I often say this, dollars drive decision making, right? And in this case, unfortunately, it's quite a high price to pay for non-productive time. And NPT could be driven from a series of factors. It could be something like maybe miscommunication to a supply chain issue or potentially crew rotation, or unfortunately, maybe a severe or a catastrophic or multi-catastrophic incident. But an unplanned NPT could range, potentially offshore drilling from $500,000 to $1 million per day. And if operations or a delay could last weeks, that's a very expensive operation to actually be undergoing. So let's look at a scenario, and we won't take a multi-catastrophic scenario. We'll take one that involves inventory and perhaps communication, and we'll look as to why this could actually happen. So in this scenario, and this is a very streamlined, very simplified sort of process. We take just two people in this operations, and I'm aware that there's multiple other personas involved in it, but for the fact of the demo, we just brought in an operations manager and a services manager. And in this case, the operations manager looks at hundreds or thousands of wells, per day, and looks at it in a command center type environment, and he watches over these wells to look at things. And fundamentally, he wants to manage the NPT and increase the ROP as specified by the operator. Right? And the second persona is a services manager. And in this case, he's the main point of contact that manages equipment, crew rotation, technology, and issues service tickets, and then actually implements, changes that come out there. His persona, his job wants to actually help limit the NPT, limit safety issues as they arrive and actually mitigate them, and also does it within the budget that actually has been constrained to. All right. We can start with this type of scenario as to why we have issues with either communication, or why we have delays in the kind of process, or the supply chain, or the inventory issues. And fundamentally, it has to do with like how these different personas see data. Right? The operation manager will get an access to WITSML, well logs, perhaps a live oilfield operation in the command center. He looks at curated data. He looks at the supply chain or the inventory around it and sees where things are. At the same time, the services manager is also seeing potentially the same thing. But maybe data in this case is copied across, so there's multiple points of truth that increase that actually occurs as data is being copied around, transferred around, or it's in documentations itself there. All of these could result in days, maybe weeks, of actually trying to reconcile the data, and it incurs these decision bottlenecks because there's manuals involved, and as you know, like equipment in the oil field, they provide by different vendors, and each vendor will have a different type of manual as the equipment isn't necessarily standardized. It's just different. And each of it has its own kind of like safety protocols and its thresholds, its operational efficiencies around it. So there's different manuals out there, and how do you, if from a service perspective, how do you reconcile all that information, right? Well, the another factor is that siloed data and solutions could result in like these duplicative efforts across it. And that, unfortunately, could result in unexpected maintenance, unexpected downtime, and it's millions lost in revenue. What we find is that if we move to this kind of like lakehouse decision model, where where you create a single source of information, a single source of truth, where you can actually then visualize it, both these personas will be able to get access to it. It's a single source of truth, so the data is actually verified and validated. Anomalies and trend can be seen in near real-time or real-time insights and dashboards. There's a lineage of data, so if there's an incident or you want to track where things are, you'll be able to fully audit that in a secure way. And you get realistic, holistic feeds and notifications, and maybe even recommendations that come out of it. So we're seeing that when people move towards this decision model powered by the lakehouse, you help to actually overcome some of the issues that you found in the indecision model. At Databricks, as we mature the energy vertical, which was actually launched officially in March this year, we are trying to help customers, exactly solve this. Not just the drilling problem alone, but other issues that actually involve assets, the environment, personalization, and we are looking to actually build a system. An example of the system could be is that helping to build energy customers unleash their full value of the assets to deliver the smarter solutions, right? We still maintain the Lakehouse Data Intelligence Platform with its simplicity. It works cross clouds itself there. It's still a unifying platform across IT, OT data itself. In this example, we're bringing in geological data, but we're not limited to that. We can expand that. This is only a sample of what we can bring in. We're bringing in, traditional enterprise data sources from SAP or maybe ERP. And we're bringing in other machine sources from your historians or your sensors out there. It lands in Databricks itself. It goes through its curation. There's a standard ingestion pattern that we use to do it. You have a smart data layer that allows you to always have an always on 24/7 operations, low latency to actually manage some of the models serving around it. At the same time, you can then democratize some of that information through the existing analytic tools. Right. If you have any questions on this, I believe there's a chat. There's people in the chat group that can actually help you manage some of those questions. Right. The next part I want to look at is the actual demo we're looking at, and I call this optionality with the data intelligence platform, right? And if you started actually at the actual core of the data lake itself, Delta Lake has a uniform data format, which allows you to simply manage your data needs. Uniform also allows us to read from Delta tables, even from Iceberg Delta Reader. So the purpose of actually building this one leg concept and making it open was that we are giving you the option of actually building the best tool to manage your workloads, right? And it allows you the flexibility to choose an architecture that will change today and also will impact tomorrow, right? We have the governance that actually comes with the Unity Catalog, and you can take advantage of the data intelligence platforms, optimizations tool. You can optimize your ETL platforms. You can use a managed data pipeline with Delta Live tables. You can even, depending on how you want the data to come in, whether it's batched or streamed, or if you want to build a job, and you can actually have these uniform workflow orchestration, and you can manage it. There's different options as to how you load it in. Our core technology will actually allow you to work with it. You can stream data in, structured streaming, autoloader. You can have quick visualizations with DB-SQL, and you can actually generate insights through that quite quickly. Databricks Mosaic will actually allow you to build unified tools for governing your AI and ML solutions. And we allow you to seamlessly integrate with different ecosystem partners, right? So you could have real-time data coming into it, or near real-time data. We can work with the database, the traditional warehousing. In this example, in particular, what we're looking at is we have drilling manuals that are specific to the different types of equipment that's on there. We have drilling data coming in. That'll be the IoT sensors that you will see. It's with some data, and then you have some maintenance data coming in with ERP. All of that is, then we leverage our Genie data rooms to give us near real-time insights. And actually, those insights power the chatbots around it. With our new AI BI tool, we're able to generate dashboards around that very quickly. And we have a Gen AI chatbot that does a summarization of this data, right? As we want to expand this kind of compound system, what we want to do is we may look at more complicated examples. We may want to issue service tickets, automate service tickets. We may want to then automate maybe even oilfield operation, depending on how it is, even generating a report. So as we develop it, the existing architecture that's part of the core for the data intelligence platform doesn't change. What's scalable and changes is just what you want to do with it downstream, right? So the answer is maybe you want to, for an example for a compound system is you may want to look at maybe whether to do an offshore deployment. That would in fact the service crew going out there. You can issue a ticket, generate reports based on it, and maybe some autonomous trigger that would actually then impact the supply chain. Right? So again, whatever your design preference is, the data intelligence platform is here to support you and allow you to actually then to become a solutioning accelerator between your source data and the issue resolution. In this case, actually, we're going to be looking at, again, an industry demo. We're going to be taking IoT data from these sensors. We're actually going to then do some prognostics based on the drilling equipment and have a chatbot actually look at it. So I'm going to hand this over to Jackson to continue the demo. Thank you.
All right, let me share my screen here. Can y'all confirm that you see the PowerPoint slides up here?
Yeah, let's get it.
Okay. All right. So thanks, Ration. So we're going to take a look at the Databricks Oilfield Operations Command Center and see how our different personas here can work together on one platform to minimize that non-productive time. So first, I'll be wearing that hat of the operations manager. And as this operations manager, really this subject matter expert, and my job is to oversee oilfield operations, right? And one way to do that is to minimize, one way to minimize unplanned maintenance or safety concerns is to analyze this data that's coming in from sensors. So things like anomalies or trends or really anything else that can help me identify red flags before they become an issue. All right, so I'm going to jump over here. So what we're looking at here is an AI BI dashboard, and this is pulling in vast amounts of real-time sensor data. Now, because I'm only one of many operation managers, I only oversee, a certain subset of drills, and those drills happen to be between 1 and 100. So if I change this to asset 19, so sensor 19, now we'll start to see some data populate the screen. So now I have some data to analyze, which means I can, start to get to work to analyze, if there's any patterns or trends or anomalies to identify those red flags. Now, the reason that I'm only able to access the data that I need to is because, if my job is to minimize the risk of burning that $1 million a day due to unplanned maintenance or non-productive time, it's really important that I'm absolutely sure that the data that I'm analyzing is, accurate, that it's consistent, that it's readily available, and that it's secure. And, without these attributes, it's more than likely that I'll miss one of these red flags that I could have, handled earlier with some preventative maintenance. Okay, so the way that this works through the Oilfield Operations Command Center is we have Unity Catalog enabled. This makes something like access management that we just saw simple and unified for whatever persona we're working with. So whether it's me now as the operations manager or later on when we get to the services manager, we can really both focus on accelerating our work without worrying about security or compliance. Okay, so I have this dashboard, right? Maybe my data team created this for me. Maybe I'm looking for some other visualization that I need, but I'm super crunched for time. So I'm going to toggle this to draft. I'm going to go down here and we're going to add a visualization. And maybe I'm interested in looking at the average fluid cavitation over time. So let's just type in, give me the average FL cav over time by minute. I click enter. And now I have this new visualization that I was looking for. So this is really where the AI and the AI BI dashboards comes into play. Because the Oilfield Operations Command Center platform has this generative AI layer, I'm able to leverage this to generate charts here just using natural language. Now, why is this helpful, right? Well, I didn't have to give my data team a call. I didn't have to wait around for some, chart to be built for me. So I sort of expedited this work. And beyond that, regardless of my skill set or familiarity building dashboards, because I can just type in natural language, I'm able to accelerate my work here. Okay, so this is really where we can enable our subject matter experts in drilling operations to make these intelligent decisions regardless of their technical acumen. Okay, so I'm going to jump back to this published dashboard here. As an operations manager, let's imagine that I've set some temperature threshold where if any drill goes above it, I constitute that as a red flag. Let's call it 75 degrees. So as I'm analyzing this specific sensor, so sensor 19, I can see that, oh God, there's been a few timestamps over the past several reads where we're, getting close to or breaching at 75 degrees. So this is a red flag for me, but I want to investigate this a bit more before I initiate any work on this. What I ultimately want to do here is I want to drill deeper into this data. I want to start asking some questions about it. So first things first, just to make sure we're covering all of our bases. Maybe I'm a little bit skeptical that this is even the right data, or I'm even starting to wonder now how all of these various timestamps of data are getting into the platform for all these drills. So let's explore that by jumping into our catalog over here. So this is my single source of truth for all of the data assets in my Oilfield Command Center. So I know I was looking at that gold data set, and gold for the Oilfield Command Center is just the cleanest, most business-ready data after any transformations or data quality checks have taken place. So I can, check a few things, like I can check permissions here and make sure that, okay, that's my name. I know that I should have access to this. These are my other operations managers. They should definitely have access to it too. So that all checks out. I can take a look at the history of this data, so I can see some, pretty up-to-date transformations or data quality checks that have taken place. So if something here sticks out, right, I know when it happened, why it happened, and also who to reach out to resolve the issue. Can also take a look at the lineage of my data. So this is a nice feature that captures all of the relevant metadata and associated events to the data that I'm working with. So for instance, we were previously looking at that dashboard. So, if I click this dashboard, I can see that, yes, this data is populating this dashboard as a downstream consumer of it. Okay, but the main reason that I'm here, right, is to make sure that that temperature data that I was looking at is clean and that I can trust it before I make any decisions regarding it. So I'm going to open up this lineage graph here, and we're going to try to find that temperature column. Okay, there it is, temperature. And we're going to start to trace this back to make sure we know exactly how it got there, if there was any transformations that have taken place, and trace it all the way back to its source. Okay, so there we go. Now we have our bronze source. We can trace our temperature column all the way from our, our gold data. We see a little bit of a transformation that takes place here between the combination of a timestamp and a float, and we see its origin in the bronze table. Okay, so now I feel a little bit more comfortable. I can trust that the information that I'm analyzing is accurate. And why this is important? Well, being able to trace this information or maybe issues if they come up back to their source, it's possible because, again, of Unity Catalog. And that's even automated for all of this data and then any new data that comes in to the Oilfield Command Center. Okay. Having this automated for all of this data and any new data that comes in really does help reduce the costs and complexities that are typically seen with enterprise data governance. Okay, so this saved me a whole lot of time, right? I was trying to hunt this information down and I was able to do so pretty quickly. You can also imagine that if there were some issue or some improper transformation that has taken place, having this lineage view would allow me to isolate that and resolve it really quickly. So, all right. Now, one other important piece of lineage is that it monitors our Delta Live Tables pipeline. So we have lineage on that too. So just to show you that, I'm going to jump over here real quick, and it's a pretty cool looking visual of our pipeline. It's streaming data, so you can see that this is running right now. From all of our drills in the field, our IoT sensor data streaming in. Now, because we have these thousands of records of streaming data coming in every minute, and other batch data as well, not just the IoT sensor data, it's really necessary for us in the Oilfield Command Center to have a data pipeline that's both intelligent and cost effective, right? So instead of having to actually manually configure this pipeline and deal with all the bells and the whistles that come with that, we've instead set up here this declarative approach to ETL where Delta Live Tables is determining the most efficient way to build and execute these pipelines while optimizing for price and performance, okay? So the way that we've set this up, we've made the data pipelining process a whole lot simpler. And with Delta Live Tables, we also get a lot of the benefits like automated data quality checks or error handling for failure recovery. So net, what this means for me as an operations manager is that I'm getting the data that I need when I need it. And what this means for the business is that we've reduced costs through performance optimization and reduced infrastructure management. Okay. So if you recall, the whole reason I started drilling into this data is because I saw that sensor 19 was breaching that 75-degree temperature threshold. So now what I want to do is really start to drill deeper into that data and start to ask some questions about it. So now that I'm on this catalog view and I can see my data here, what I can do is create what's called the Genie space. All I have to do is give it a title, and it already knows the data, and I click save. I already have one created for this, so I'm going to jump into that right now. Okay. Now, with Genie, I can start to have this sort of natural conversation with my data, really going a bit beyond what I might get out of dashboards. So if I ask something like, is device 19 broken or failing? So I ask a question like that, and because Genie has this semantics, understanding of the semantics of my data, I can get an accurate answer. So you'll see the reply that I got here is that this temperature is greater than 75. This could be used to identify instances where the device is potentially broken due to high temperature readings. And yes, unfortunately, we can see the last several timestamps of this sensor's fluid temperature is at 80 degrees. So that's, breaching my 75-degree threshold. And I've unfortunately confirmed to myself that there's a red flag here that I might want to handle. Okay, now just to paint the picture of what's happening behind the scenes here is, again, because we have this generative AI intelligence layer built into the Oilfield Operations Command Center, it's possible for us to automatically generate SQL queries based off just this simple natural language question. What that means is that I don't necessarily need to have the technical skills to get these answers and get them quickly. Again, closing that technical gap and creating a more efficient process for managing the drills that I do. If you're interested, when I click show this code, we actually see the SQL query that was written. So maybe if I did have SQL skills, I could use this as a starting point, or I could edit it more. Either way, I have the ability to work with it. Can also rate this response as either a good response or a bad response. And as the subject matter expert, right, the ability to help Genie improve its responses over time, this will ultimately make my effort to fastly and accurately respond to equipment issues and minimize the likelihood of unplanned maintenance even better, because we have better answers coming from the subject matter expert. Okay, so this far in the journey, we've seen how real-time sensor data is streaming into the Oilfield Operations Command Center. We've seen how the operations manager works with that data to search for red flags, and we've confirmed that a red flag exists, right, for sensor 19. So at this point, what I'm going to do is I'm going to initiate a service request for my services manager to get the right parts ordered or to schedule some type of work. So just for the story, let's imagine, again, I'm the SME in this space. I've pinpointed this issue to be a faulty blowout preventer, or BOP, that needs to be fixed or replaced. So that's what I included in my service ticket. Okay, so now wearing the hat of the services manager. This individual is, a supply chain logistics guru, but it's the first time in industry, right? So they just received a service ticket that says fix asset number 19 BOP. I have no idea what a BOP means, right? So as one does, I'll jump into a large language model and I'll type in what is a BOP. Okay, let's see. We got some music here. We got some dance, fashion, internet slang. Okay, and all right. So, although I might be new to industry, I'm pretty sure that I didn't get a service ticket about, music or dancing, right? Here lies one of the limitations of base level large language models, especially when we're working with industry specific questions. So these base models are incredible. They have a wide array of knowledge, although they often lack the industry-specific information that is helpful to someone like me in this situation. So luckily, we have some smart people working at the Oilfield Operations Command Center, and they've leveraged some of the embedded tools within this platform to personalize this model to be an expert assistant for industry. So if I hop over to this simple user interface and I type in the same question, what is a BOP? We can see now that I'm getting, a more correct answer. I'm getting that this is a blowout preventer. So now I can quickly order the necessary parts to fix this device, and I don't have to play any telephone tag or, slow down this process by trying to hunt down exactly what this service ticket was about. Okay, so behind the scenes here, what my data scientist team did is they built this using a framework called retrieval augmented generation, often referred to as RAG. All this means is we're leveraging some industry-specific PDFs to augment the base model with some relevant context that the model actually needs to help someone like me. And we can do the same thing with semi-structured data too. So we also have some maintenance logs in here, just to show you what they look like real quick. It's just some JSON of past, maintenance issues, how they were resolved, just so they might help someone in the future. So let's say I have, an issue where I'm thinking, the hanger hook looks a bit enlarged, looks enlarged. Same thing's going to happen even with the semi-structured data, is we're going to be able to semantically search the logs and provide a solid response to the steps that I might be able to take to resolve this issue. Okay, so this is an example of what we call a compound AI system, where we have this orchestration of large language models and traditional technology, and doing so to increase the accuracy and the efficiency of the responses. And moving forward, the system could be evolved even further with an additional layer where we can route, questions to our Genie space that we saw a bit earlier. So our answers can be actually supported with our numerical IoT sensor data. So net, right, whether it's the unstructured PDFs, whether it's the semi-structured JSON logs, whether it's the structured sensor data, we can work with it using these compound AI systems. And just as a statistic, right, we've seen that these compound systems improve accuracy from 59% on average to around 85%, and reduce our latency from about 15 seconds to 6 seconds. So pretty significant improvements. All right, I'm going to jump back to the slides here and just recap what we just saw. So starting from the left, we saw how various data sources, from streaming to batch and, from structured to unstructured, how all of this was ingested into the platform. And once this data was in the platform, we saw several instances of, unified governance through areas like access control and data lineage. And we saw several instances of data intelligence. So things like the AI BI dashboard, the Genie data room, and finally, most recently, the oilfield maintenance assistant. Ultimately, right, the key takeaways here are that this is one platform that both the operations manager as well as the service managers, could perform all of these disparate tasks on. Everything from data engineering to business analytics to generative AI. This really allowed for us to streamline the whole process of minimizing the non-productive time through the ability to intelligently monitor our data and make decisions with it. And once again, right, if the overall goal here is to minimize non-productive time, we need to move fast. And to move fast, we need to break down silos, and we need to be able to trust the decisions that we're making because we're backed with the data, our most valuable asset. Okay, so to wrap up, we were able to rapidly fix the issues with Drill 19. We didn't encounter that $1 million a day for NPT, so happy ending to the story. And yeah, thank you all for listening. I hope you enjoyed the demo.